Hello again, everyone. Last time, we talked a bit about quadratic equations and parabolas. Today, we will be exploring a method of both solving quadratic equations, called the quadratic formula, and then we will interpret those solutions on a graph. To begin, let's return to equations with only one variable, x. These equations could have quadratic, linear, and constant terms on either side of the equal sign, with our goal to find a value of x that satisfies or solves the equation. Whenever we encounter something like this, our first goal should always be to move all terms to one side of the equation, leaving 0 on the other side. Let's take a look at this equation here to demonstrate the process. First off, in order to move things between sides, it's best to go ahead and distribute this 3x into the parentheses. Doing that gives the left side still the same. Now equal to 3x times x is 3x squared, plus 3x times 2 is 6x. Now that everything is distributed, we want to get everything to one side of the equation. I'm going to move everything that's on the right side over to the left, and to do that I will need to subtract it from both sides. Subtracting it cancels it out on the right side. And then combining like terms on the left, 5x squared minus 3x squared gives 2x squared. 3x minus 6x gives me minus 3x. Then I still have this plus 1, and now that will be equal to 0. And with that, we've completed our first step of moving everything over to one side of the equation. Now that we have everything to one side of the equation, there are a few methods we have available to solve. One method is to utilize factoring. We talked about factoring earlier in this series, and have a few videos available on how to use it in this context. But for this video, we will be focusing on another method which is more universally applicable. We will be discussing the quadratic formula, but before we give the formula, recall that the standard form of a quadratic looks like ax squared plus bx plus c, where we label the coefficients of the x squared term as a, the coefficient of the x term as b, and the constant term is c. With that notation in mind, the quadratic formula tells us that the solutions to the equation, where this standard form is equal to 0, are given by x equals minus b plus or minus the square root of b squared minus 4ac all over 2 times a. This is our quadratic formula. And it gives us two solutions, one where we use the plus between the b and the square root, and one where we use the negative between the b and the square root. Let's return to our example in order to practice using the formula. Once we got everything to one side equaling 0, this is what we had. Let's pick out our a as the coefficient of the x squared, which is 2. The coefficient of the x term is actually negative 3, because we typically define the b when there's a plus in front of the x. And finally, the constant term is just positive 1. With these numbers in mind, we can plug into our quadratic formula. Always be careful to put any negatives in parentheses, and just plugging in the numbers a, b, and c will give us something that looks like this. From this point on is just doing the math. The negative in front of the negative 3 makes this a positive 3 now. Now plus or minus the square root of negative 3 squared is 9. Minus 4 times 2 times 1 is minus 8. All divided by 2 times 2 is 4. Inside the square root, 9 minus 8 is 1. When we take the square root of 1, we just get 1. And we've reached the point where we'll need to go ahead and separate the addition and subtraction cases. Our first solution from addition comes from 3 plus 1, all divided by 4, gives us 4 over 4, which is just 1. Then our other solution comes from the subtraction, 3 minus 1, all over 4, gives us 2 over 4, which simplifies to 1/2. So we get two solutions to this quadratic equation. X could be 1, or x could be 1/2. In most cases you run into, getting two solutions is what you would expect. However, that isn't always the case. There are actually three different cases for the results: two real solutions, one real solution, or no real solutions. The cause of this comes from what we end up getting inside of the square root, which comes from the b squared minus 4ac term. We call this expression the discriminant. When this expression ends up being greater than 0, like in the example we just worked, this is when we get two real solutions. However, when the discriminant ends up being exactly equal to 0, we only get one real solution. And finally, when the discriminant is less than 0, or negative, this is when we get no real solutions. And the reason for this is because we would end up having to take the square root of a negative number, which we cannot do. Let's quickly take a look at these quadratic equations and use the quadratic formula and see how the discriminant affects our answer. For the equation on the left here, we see that a equals 1, b equals 2, and c equals 3. So plugging this into our quadratic formula, we will get x equals minus 2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. Doing some of the math here, we get minus 2 plus or minus the square root of 4 minus 12 all over 2. What we get under the square root becomes 4 minus 12 is negative 8. So our discriminant here is less than 0, and we're trying to take the square root of a negative number, and this is why we get no real solutions. Meanwhile, for our example on the right here, a is 1, b is equal to negative 4, and c is equal to 4. So plugging this into our quadratic formula, we get x equals negative 4 is just 4, plus or minus the square root of 4 squared minus 4 times 1 times 4 all over 2 times 1. This ends up giving us 4 plus or minus square root of 4 squared is 16. Minus 4 times 1 times 4 is minus 16 all over 2. And what we're left with under the square root here is 0. So our discriminant here in this case is 0. Taking the square root of 0 gives us 0. And our solutions become 4 plus or minus 0 all over 2. Now whether we add or subtract 0 from 4, we're still left with 4 over 2, giving us just one solution of 2. And as you can see, when our discriminant is 0, we only got one real solution. Now that we understand how to use the quadratic formula with quadratic equations only involving x, let's return to functions with a dependent variable y. If y now equals a quadratic function in terms of x, how can we use the quadratic formula here? Well, remember, in order to use our quadratic formula, what we need is an equation that has 0 equal to ax squared plus bx plus c. So what we are effectively doing is we are setting y equal to 0 and solving for the x that makes that happen. When we do this and use our quadratic formulas to find the solutions, what we will find, assuming real solutions, is that there are one or two x's that when plugged into the equation give a y value of 0. I'll call them x1 and x2 for now. So assuming these are the solutions to when we set y equal to 0, we call these solutions the zeros of the quadratic function. We call these solutions the zeros of the quadratic function. By getting these solutions, we also know that plugging them in will give a y value of 0, which means the points x1, 0, and x2, 0 are on the graph of our function. And since they are at y equals 0, they are also our x-intercepts. So if we have a coordinate grid and are interested in what the plot looks like, once we know x1 and x2 are zeros, we know that they are right here on our x-axis. Finding these zeros, as well as the vertex of a parabola, which we discussed how to find that last time, let's say it's down here, is often all you need in order to plot what the graph looks like. So as you can see, finding these zeros can also be helpful in visualizing what the graph looks like. Solving quadratic equations comes up in several different areas with many applications. And being the most consistent way to solve these equations, the quadratic formula is a crucial tool to understand and be able to apply. Until next time.